So let's get started with the orchestration primer.
All right. So I really want to keep it very simple for everyone to understand firstly what orchestration is. And for that, I'll pick a very easy to understand use case. So I want all of you to imagine a chef in a restaurant. A chef in a restaurant. The chef has to prepare a full meal, right? The starter, the main course, the dessert. And some dishes can be cooked in parallel for sure, but some dishes need dependencies. For example, you cannot garnish the dish till it's cooked, right? So there's a dependency there. Also, imagine if something in that process goes wrong. Okay. Now the chef will have to retry, but he has to be smart enough to retry just the piece which has failed and not the entire meal, right? So that's again the responsibility of the chef. And he also has to keep track of time and make sure that everything is checked and everything is ready before serving, which can also be called as monitoring and logging in airflow terms, right? So just like this, orchestration in data pipelines is all about managing dependencies, managing risk, scheduling, monitoring, and logging. So the whole workflow can run smoothly and end to end. I hope that clarifies a bit about what orchestration is. Now, let's deep dive back into the 2010s. So, back in early 2010s, the data orchestration really lived in the world of Hadoop. Everything was about batch processing, MapReduce, Hive, Pig, and everything was on premises, right? Tightly coupled to the Hadoop ecosystem. The focus was really on getting it to work rather than focusing on flexibility, right? So Uzi, for that matter, was the first orchestrator for Hadoop, and it was created by Yahoo back in 2010. This worked well for that time. Of course, it did. But as data grew, the needs started evolving, right? The batch only and the rigid systems were not enough anymore. And that's why we started seeing the cracks. That's why the need for something more flexible came into the picture. So, yes, Uzi could schedule Hadoop jobs very well, yes, but it also came with a lot of challenges. So on the screen, you see a snippet of um, an Uzi workflow, the XML file. If at all you've ever worked on Uzi, you'll know what a pain is to deal with such a config file, which is so heavy and it's so hard to debug, right? So the developer experience in itself is poor. There's no easy logging. There's no good testing tools. And it's again tied to Hadoop only, right? So let's say you want to use Spark outside of Hadoop. What do, right? And it's also not cloud native. It's not scalable. And that is really much what is required for the new world of distributed systems, right? So, in a nutshell, while Uzi was the chef of Hadoop kitchens, if I may say so, it could cook only a couple of cuisines with very complicated recipes. And the industry really needed an orchestrator that was more flexible, more modern, easier to use. And that's where Airflow started rising.
Exactly. So when the industry needed and the community came with the Airflow. And before it's getting started, I will introduce what Airflow is. I mean, it's an open source platform and for developing and scheduling monitoring batch workflows. It was born at Airbnb around 2014. Then it later became the Apache Airflow project. So some of the features of Airflow, which I personally think is good as compared to the Uzi or when we talk about the migration. So the first thing is Python native DAX. I think the Python is the go in today's world. The Python is go-to for any of the new developers or who are working upon. It's very there is a very low learning curve for anyone who is starting with the Python. And the DAX written in the Airflow is probably starting with they write in the Python DAX. And the separation of concerns, we have different components for different things, such as schedulers, executor, worker. So it is not very dependent upon or is tightly packed with. So, and the rich extensibility is one of the things which make Airflow very great, which is plugins, custom operators, and macros. We have a lot of providers, as you can see on the Apache Airflow websites. We do support a lot of providers, which is something like Google, Snowflake, Cloudera. A lot of things are there, right? So UI for monitoring logs, we have a very good UI in which you can see visual tags, log variants, or retries. And the last thing, it's one of the important thing, which is cloud and container friendly, right? In today's world, in the Kubernetes world, where we have the cloud things, so it's very important to work. The project should work with the K8s, Docker, or the cloud infra. So that is done with the help of Airflow. And the last one is dynamic DAG generation. This is one of my personal favorite, which is you do not need to write if there is some template issue. If you can have multiple tags in a template format, you can do it with the help of dynamic tag generation, right? It will on the runtime, it will generate that tags and help you out. So as you can see on the screen, the rise of Airflow, there's a lot of comment. You can see the exponential growth of Airflow project from 2015 to 2025. It's been growing exponential. And for any of the project, the success is defined from how many contributors you have on the project. And we have near about 3,448. That's a huge amount of contributors for any of the projects. So I wanted to give you a glimpse about how the evolution within the Airflow happened. So as you can see, this is whatever version I am pinged on the screen. This is the latest versions from each of the bigger releases for Airflow 1, Airflow 2, or Airflow 3, right? So you can see how it evolved around the time. The 1.10 have some basic stuff with carried over. We went to 2.11 in the 2.x version, and then currently in 2025 we are in Airflow 3, and the latest version we have is currently is 3.0.6. So coming to the what all features we evolved with the Airflow. So when Airflow came, it came with the Python DAG, but static and verbose. Like we have a single scheduler. Most of the enterprises will prefer to have a multiple or HA scheduler with them. Then we had some basic UI, and there was a tight coupling between the components. The scalability was not that great at that particular time. But then we came with Airflow 2, where we have TaskFlow API. The user experience or the data engineer's experience smoothened because it's easy to write the tags with the TaskFlow API. Then we also have dynamic DAGs. And then again, one of the good feature like HA scheduler was HA scheduler came in Airflow 2.x. Then we have smart sensor, differable operators. So whoever uses this, they know how big is the pain of having the resource crunch, and also we do get help from these things. And then the provider ecosystem. One of the best things which make Airflow great is the ecosystem of the providers, what it provides. You can connect with much more providers or the operators throughout the world. And then come the most awaited Airflow 3 version, which we have in 2025. And this comes with one of the bigger feature, the task execution API, which is AIP 72, where we have restricted the talking to the DB directly from the tags. And of course, we have this talk, the next talk shared by Amog is on AIP 72. Then we have Edge Executor and tag bundle and tag versioning. We also have tag versioning this time in Airflow 3, which helps you to know the versions of your tags, what you have upon. And then we have new SDK and the much more awaited Airflow modern UI built upon the React plus Fast API with a lot of cool features. So before moving forward, I really want to give you the new Airflow 3 UI walkthrough. So as you can see on the screen, this is the first homepage of Airflow 3. It comes with a dark mode. It's my personal favorite. And this have all the summary about how many failed DAGs you have, running DAGs, active DAGs, then all over the what all health are for the different component scheduler, trigger, DAG processor, and then the assets, events, whatever all are here. Sure. So now this is the DAX page. This is the card view. You also have a list view. And this is the trigger tag page where you can give logical dates, give your diagram notes, configurations, and all. And when you can trigger your DAG from here. And see, you can see the running DAGs. And this is the runs page where you can see all your runs. And then this is the task instances phase. You can see all your tag IDs with the tag run and task. This is the assets page. And similarly, we have for XComs, this is the page. And in admin, you have multiple pages, variable, pools, provider, plugins, connections, config, a lot of them, right? This is the providers page. So I just really wanted to just give a glimpse or touch things upon like what all things in changed, how the Airflow 3 UI has been changed. Okay, can I take the questions post-event? It's a data sets before, yeah.
All right. So now let's talk about what is Cloudera bringing to the table in terms of its standalone Airflow offering, right? Here's a demo, but before I quickly play that, let me just try to explain what we mean when we say Cloudera standalone offering, right? So we all know that open source Airflow is great. As Shubham said, it's flexible, it's widely adopted. But in enterprises, especially where most of our customers are today, there is a need to have something which is not just an engine. You need reliability, right? You need integrations. You need security, right? This is where Cloudera standalone Airflow comes into the play. We are focused primarily here on three things. The first is seamless integrations within the Cloudera ecosystem. So we provide out-of-box operators for Hive, for Spark, for machine learning, and more. What this means is that you don't have to spend weeks building and maintaining your custom connectors, right, to these services. Your workflows just work across the data warehouses, the data engineering, and the AI use cases that you have. The second is enterprise-ready infrastructure. What I mean by that is that standalone Airflow deployment is tuned in a way that it can support both on-prem as well as cloud environments. And we do provide built-in support for Kerberos, governance, security controls, and that's what enterprises really rely on, right? We do provide high availability and fault tolerance, so business critical pipeline don't just fail at 2 a.m. suddenly, and you don't have anything to do about it, right? So we ensure that doesn't happen with you. And third, and not the least, is the simplified operations and lower TCO. What I mean by that is we have our managed packaging, upgrading, scaling, and monitoring that is all streamlined for you. You don't need to spend time firefighting, and rather you can spend that time delivering the actual business value, right? So yeah, so compared to open source Airflow, where teams often struggle with the DIY deployments, our approach with standalone Airflow really reduces the operational overhead for your teams and accelerates the time to value. So let me quickly show you what standalone Airflow looks like. This is an early preview demo, which really captures a real world use case. So yeah, let's get into that.
We'll start here at the Cloudera console. You can see that I've got an environment here where we've set up, Rohit in fact, have set up these two Airflow clusters. We have two different versions. We have Airflow 3.0.2 and 2.11.0. The 3.0.2 Airflow cluster is for marketing, and the 2.11 is for sales. Find that DAG in that sales cluster. Let's go take a look. Okay, once we're here, we can open up the Airflow UI. Here's the DAG in question. So we're going to investigate that. Now we've run it before, so you can see a history as we're setting up this demo. Let's take a look at the actual graph here. Now I'm going to zoom in on this. So, as I said, the Airflow DAG starts with waiting for updates to an S3 file. That's where the employee data is. It downloads and parses that JSON data and then validates it. And then it branches off and uses the CDE run job operator to start a Spark job. Also, it ends up branching off and running the Python operator and the SQL exec query operator to create a Hive table, and which happens to be an iceberg. And then finally, it also prints the employee names. Okay, let's get it started. Okay, we can go back to that graph view and actually watch how the upgrades or updates happen. You can see the job is queued. Now that the job is started, I'll speed it up a bit so you don't have to wait so long. Be right back. That's a success. Fantastic. Let's go take a look at that Hive table and the Spark job logs. Okay, so here we are in Hue. This particular instance of Hue is attached to our Hive instance. Now, you don't see, in the default space, you only see a test table. But now you see the employee table. It's got a variety of columns in it. Let's see what's in there. There we go, 3 employees. Fantastic. Let's go take a look at that Spark job. Here I am in Cloudera Data Engineering. I'm looking at the default virtual cluster where our job is defined. You can see that the job is actually running right now. What we're going to do is take a look at the logs from that job. Okay, the job succeeded. And you can see that it's creating a root folder and is saving some data into S3, in fact, an iceberg table. And you can see the data here. Fantastic. For the last step, let's provision a third instance of Airflow in the same environment and the same Kubernetes cluster. Start with the application catalog in the management console. Select Airflow. You can see there are 2 available versions. Clicking the Provision Application button opens the form to provision a new instance. The name here is going to be Hello Airflow, and this one is for the engineering group. We'll select the newest version. I'll choose the environment that we use for the demo and the default compute cluster. In this case, we want the most cost-effective deployment by choosing the small instance size. Clicking the provision button starts the process. Okay. Now we have a third instance of Airflow. Great. Select a new instance and we can launch the Airflow dashboard from the endpoints list. Awesome. And that concludes our early preview of Cloudera Airflow. Cheers!
All right. I think the business value with the standalone Airflow is pretty much clear now. The faster onboarding that we have with ready-made integrations, the reduced risk with enterprise security and support, and of course, lower cost of ownership compared to the very popular open source Airflow alone. So in short, we are not reinventing Airflow. We are making it enterprise grade, reliable, ready for the customers and the kind of scale they operate at.
Exactly. So the next thing what we see in today's world is AI, the AI frontier of anything, whatever. So this time I'm going to talk about AI powered future of Airflow or the developer experience with the help of AI LLM models or with the type of Airflow or. So first thing, the LLM based DAG generation. With coming LLM world now, users or data engineers are comparatively writing the DAX faster with the faster development, and there is very lower barrier to entry. So even if, of course, there is a very low level things needed to write a DAG, but even if you do not have that information or the knowledge about it, you can every time get it from the LLM-based DAG generation. So at least that lower barrier has created to get the entry in that. Then using the MCP, right? So improved traceability, or with the help of ID also, you can talk to the Airflow and see what all DAGs are there, or you can trigger a DAG run, or you can submit a DAG, all with the help of just being on the same ID platform. And then the proper use case of AI-powered workflow, which eventually happened before also, like lot of ML model, lot of ML things which forecasting optimization used to run on the Airflow, or the anomaly detection, which is one of the like good things which you can do it on the Airflow with offer use cases, right? So I have it's a small demo recorded. This is more about the developer experiences where you have a DAG generation and the ID, and with the help of MCP, you trigger a DAG from the same ID and see all the workflows running from the single instance. So for this video, I'm using standalone Airflow. This is the latest offering from Cloudera, and the Airflow version what I'm using is 3.0.2. So today, team waste hours building and configuring workflows just to move data from A to B. For example, like pulling files from S3 and sending them to an inbox can mean writing scripts, setting up connections, testing a lot, right? What if instead you can just simply say a prompt to an ID and it does everything for you? So on the screen, you can see that I have given a prompt that can you write a Airflow 3 compatible tag, and eventually it will fetch data from S3 and get the files and mail it to the particular mail ID what I have given. Let's see what it generates. So as you can see that it is trying to generate the DAG file and with the name of send data to mail.py, and the DAG file is generated and the file looks good. And I will remove some of the options which I don't need, like retries and the catch up. And I think we are good to go, right? So let's merge this to my GitHub repository, which is eventually connected to the Airflow environment. So it will take some few seconds to get synced with the Airflow environment. You can see 85 tags are currently present in the Airflow environment. So it's better than waiting. We will ask the ID that can you check if you have the tag with the following ID and see what it says about it. So it's trying to get all the tags and eventually it found that the tag is already present. And you can see 86 number of tags are already present. Now I have asked it to unpause and trigger a tag run for me. So you can see it unpaused the DAG and it has successfully triggered a DAG run also. Let's see on the UI whether this DAG run is there. Yeah, the DAG is already running and the first task is already completed and the second task is queued. So you can see the process was very seamless, right? So let's go to the inbox and check whether we have received the mail. Fantastic. So the mail has arrived. You can see how fast we got our workflow running. So as you can see, with the help of AI with Airflow, you were able to get your DAX first. But of course, with all of this power, there's a lot of things to improve with the time, and the developer experience I am confident about, will improve one by one more about it. But meantime, we also have some, you can say, problems, or we need to work upon it, which is like when you generate a DAG with the help of LLM, there's a lot of code quality concerns. And like suppose in enterprise level, whenever you generate a DAG, you also need to follow all the security things, what you do, and a proper review of the things has to be done when you are running an Airflow DAG in the production, right? And it's of course dependent upon the prompts what you give and based upon the models what you select. So that all things are some bottlenecks which we are figuring out by day and how it's going to. Using MCP, that's still some overhead is involved. You need to integrate with the product, existing product, or you need to integrate with the ID. So this is something which you need to do out of the product, and someone might be overwhelming for the first time users or who is setting it up. And for AI powered workflows, debugging difficulties might get sometimes. I mean, there are a lot of things which AI could also not eventually think of when you are have worked upon the whole the pipeline, and might get it very faster, right? And the model drift can one of also the problem whatever you have upon. So I mean, these are the problems, but I won't say problems, but because this AI is here to improve the developer experience, and with Airflow, I am very much sure about that. This is going to be increased day by day.
All right, so before we wrap up, we really want to leave you with one clear takeaway. So Cloudera standalone Airflow is entering the technical preview. This is your chance to enroll into the tech preview and be the voice and help us shape the GA of the product. Your feedback is extremely valuable, and I really want you to invite us, not just the user, but the co-creator for standalone airflows offering at Cloudera. Let's build this together, guys. And yeah, feel free to connect with us over LinkedIn. And yep,
Yeah. Thank you for your time. Feel free to connect. We are here till the end of the
guys,
event.
thank
Thank you,
you. Have a
everyone.
good time.
Anyone have any questions for now? Even if you do not, we are here for the whole the event. You can connect us post the event.
That AI-powered future, right? Is it built on top of the Cloudera, or is it like a
So
open source?
this is not something which we are shipping out of the box for now. It's in the previous state, but you can do it with any of the either it's enterprise ready Airflow or either it's an open source Airflow. This whole idea, my point was to show that you can use AI with any of the Airflow versions, whether it's an enterprise or it's the open source. This is a developer experience I was talking about.
Okay.
Plan for the GA, and we
Yes.
love to have your feedback. Like to see it in the field.
Okay.
Yeah.
I'll connect.
Anyone else and having questions?
Hi. So just now you have showed Airflow with using MCP. So just want to find out whatever DAX it is generating, will it be efficient? The DAX will be efficient, or will it degrade the performance of scheduler or something, or how it is?
So you need to understand that MCP do not actually give the performance bottleneck or something. It's just the tools which is using. And for this, whatever I use, this is a very basic MCP tool, which is taking actually calling the APIs and all. So it's more over like you are not doing some LLM models in doing it for you. So it won't hit the performance of anything
Okay.
for
Yeah,
now.
thanks.
So Airflow as open source, we do not provide MCP out of the project, but there are a lot of open source MCP for available for the Airflow on the internet.
How do you guys compare against Astronomer? Astronomer also does the similar, like inbuilt.
Astrom is mostly on cloud, right? So what we support is hybrid, right? So that's the clear distinction we have.
Thank you, everyone.
Thank you so much, Shubham and Shreya. It was a very nice presentation. With that, we'll call Amog from Astronomer for the next presentation. Thank you.
Pool, and similarly 1,000 for 1,000. So, and this is me being really lenient. I'm sure it's much more than that. So what does this really lead into? It leads into a situation where your connection pool is exhausted, your and the funny part is we recommend the recommended database for deploying Airflow is Postgres, and the really funny part is that it has a default of 100, and yeah, that's a big issue. Following that, every task has a new database connection. Then database definitely becomes a bottleneck in your scaling journey. And finally, horizontal scaling will hit a wall for you, and that's the end of it. The last problem that I want to discuss is dependency hell. So let's say there's a company where you have a platform ops team that deploys Airflow for you and does the deployment work. And there is a data team which one fine day decides that they want to bring in a custom operator with such requirements with Pandas 2.1, SQL Alchemy 2.0, and NumPy 125. But the data teams are kind of agnostic to what Airflow has deployed because it's not part of their job. So they don't know about it. So when they, little do they know that Airflow has these requirements, Pandas 150, SQL Alchemy 1.4, and NumPy 121, each of the things conflicting with what the task wants. But obviously data team did not know. It was an honest mistake, and they upgraded their Pandas to 2.10 just to try to install their operator. So what happened? Big bang. Pip install fails. If they're not careful, tasks can bake in production, and this will definitely be a rollback nightmare where they might have to work multiple weekends to fix it. So all problems, right? Uh, so what if I told you all this is because of Airflow 2 architecture? So that's the architecture that most of us in this room are familiar with, but just a quick recap. The scheduler is the heart of Airflow, which monitors tasks and DAGs, and it schedules the TI when their dependencies are met. Executor is more like the configuration property of the scheduler, where it decides when and where a particular task will be run. Web server, it just hosts the UI as well as the public REST API. And the metadata database is nothing but the brain of Airflow. It stores everything you need for Airflow's basic functionality. Similarly, coming to this sites where the users interact with DAG processor, it parses the DAG files in the DAGs folder and stores it as in the serialized format in the DB. Similarly, triggerer is responsible for running asynchronous code without intervening the workers, and workers obviously execute the task. So where's the problem here? First problem, this blazing red arrow. And this was the one that caused you some sleepless nights. So bigger issues, this is a big monolithic design, right? It's like a, you know what, have you played Jenga before? It's basically Jenga. You move one thing and it'll crumple up. So the second big problem here is that the DAG code that the DAG authors write. Have you seen the syntax? It's usually like from airflow.models.dag import DAG. So what is airflow.models.dag? It's basically the core of Airflow or Airflow's code base, right? So they're essentially using Airflow's code base to write DAGs. So what happens if the code base changes, upgrade or downgrade? These guys will definitely be affected, and they will have to do a lot of rework in order to fix that. So similar with triggers, again, uses Airflow's code base. And the best part is the workers. The workers, again, use the full code base to run the tasks that are written by using the code base again. So what happens is that if the code base or the core is changing at any point, the workers which were very happy running their tasks will start to experience a downtime because they do use that part to run it. So not a great place to be in. So what would be a natural human instinct here, right? The red arrow, it's kind of bothering all of us, right? So what we did is we just went and chopped it off to mitigate the risk of the database access from user code. So we just went ahead and chopped this link. So does this have any rippling effects, right? It'll definitely have it because things are not, I mentioned it's a Jenga block, right? So it's not that easy. So how did we do this? We treaded very, very carefully, and we went back to the times of our college where we learned design principles, and separation of concerns came into good play here. So it simply mentions that, you just divide an application into distinct independent sections where each section can address a specific functionality. Simple English, but how does it work here? So going back to the architecture, if I draw a nice barrier around things, right? It's carefully done. It's not just random barriers I've thrown in. So everything on the left-hand side, as a DAG author, do you really care about it? Do you care where the scheduler is running? Do you care? You use the web server, yes, but you don't really care what is running there. As long as you can get your DAGs running and even better, if you're a CLI user, you don't even care about the web server. Similarly, the database, again, you care if you're doing naughty things like I did that time, but otherwise, all good. You don't really care about it. But everything on this side, which is the DAG files, that is your job, right? You're a DAG author. So if you have to write DAG files, you definitely have to be linked to the DAG processor in a way. Similarly, triggers, somebody tells you to write some asynchronous code, you have to care about the trigger because that's the component that will run it for you. Workers, definitely you have to care because who else does the task running for you? So this is a clear, if you can imagine the left-hand portion as the server, this is basically the client. So yeah, in simple terms, Flask app versus a Postman. That's all you care about. As long as you can send the request and that guy can handle it in some way and provide a response, you're good. But we realized one thing, right? We went and we just bravely chopped off this link. But triggerers and DAG processors might also need the database, because end of the day, you still can do things at the passing time. So can I just go and chop it off like that? No, really. What happens to connections, variables, XComs? What happens if I just chop it off? So I can't just do that because it seems right. So what we did is we kept those things in mind and we made Airflow 3. So now the key changes here are the web server has been replaced with something known as the API server. It has 2 sub apps where the core app does exactly what the web server did earlier, static JavaScript UI followed by and a public REST API that people can interact with. But there is a new application now, which is known as the execution app. So the execution app provides a REST interface for workers to talk to the database. So we basically got rid of workers accessing database by throwing in a proxy there. So that is a very common pattern that has been followed in many, many softwares. Now the workers, in order to talk to the database, have to go through the API server. And how do they do that? They don't have to have the entire Airflow core installed on them. They can just have a slim interface or a slim SDK known as the task SDK, which is installed on the workers, the DAG processors, and the triggerers, so that they can talk to the database through the API server or an in-process API server. This will eventually be separated out to talk to the API server, but in the interim, it's an in-process one, but it doesn't really talk directly. So we kind of got rid of that problem. So the other change that the DAG authors experience now will be that they will author their DAGs, tasks, triggers, notifiers, name it, with the Python SDK instead of doing from airflow.models, whatever. We didn't like that. Right. Every component like the triggerer, DAG processor, and the worker they're going to talk to APIs. They're going to go through the API server to talk to the database, either through the actual API server or an in-process variant of it. And moving forward, we are releasing 3.1 maybe very, very soon, like end of next week or so. But a little more time, around 3.2 phase, we will we'll reach a stage where the providers in Airflow only need to know Task SDK, as well as the DAG authors. They will not have to care about core at all. So I do have a short demo as well. Let's see, I'm being slightly brave here. I'm trying to do live, but okay. No. Okay. Let's see. Oh, okay. Once. Okay, great. So yeah, let me try with a short demo here. Okay, this is the Airflow 3. I think it's 3.1 now, but this is the Airflow 3 UI. So I'll try to run the same dangerous tag from earlier in Airflow 3 to see if it brought down the entire thing like Airflow 2. So I'm just going to trigger it. So yeah, if it was bad by now, things would have crashed, but it doesn't look like it. So right, you can see that in Airflow 3, we do not allow things like, doing the same thing that I showed you in the slides, where I'm dropping the table and trying to do things through session. We don't allow it, and we block the database access. So right, that thing where you brought down the entire thing is not something you need to worry about. Now, the second thing I want to show is a similar problem to what the data team ran into, right? Where they had their custom provider return, which they were not really able to use because of conflict with the core. So I do have a simple custom provider written. So yeah, this is not something we look into, but one thing I want to show is let's check what version of NumPy or Pandas our Airflow core has. So it's a 1.26.4, right? And now my provider has it has a version which will definitely conflict with it. So I have a 2.0. So ideally speaking, this should have broken in Airflow 2, but that's not the case here. So this particular tab is for the workers. So let me just zoom in into this. Right. So let's try installing that particular provider here. So I have it mounted here. Net files. Yeah, it's this one, right? So, oh man, live demos suck. Yeah, so let's try installing this. I'll just run a. Okay. Let me install my custom provider. So all good here. It installed the other version of Pandas. It installed NumPy 2.0. Nothing failed so far. Pip install went fine. So let's try actually running that thing. So what does the provider do? It's obviously a ChatGPT generated one, which just takes in a few things like your NumPy version, the operation to perform, and some quarks, right, which is the actual data. So yeah, it does something very simple. So I'm just going to do something simple again. So I have a simple Python file written here, which just it imports that operator, it initializes it, and it executes it with 2.0 NumPy version, operation sum, data 1, 2, 3, 4, 5. So I'm just going to run that. Okay, so yeah, it went past, it gave you the sum, it did not crash, so we're good. And that's because the Py project toml that I had does not have core as the dependency. It's just the task SDK, and task SDK does not have conflicted dependency, but it's because it's a very slim package. And this will be the future of providers very soon. Okay, getting back to my part. Sorry, 1 second. Yes. Okay, let's start sharing again. Okay, cool. So yeah, that was the demo I wanted to show. And so this whole thing was designed through an AIP Airflow implement proposal number 72. So how did we really, I'm sort of recapping here, how did we solve the security issue? So we blocked the ORM access from user code. We made sure any DB operation goes through API server. No database credentials are present on the workers. And for the authorization, every task is assigned a JWT token when it's starting up. And this token is used for every API request that goes through the task execution interface. And whenever the token expires, it is reissued by the API server as part of its response headers. In terms of scale, this is the graph from earlier, order of n, 1,000 tasks having 1,000 plus database connections, database becoming a bottleneck, yeah, and all sorts of problems, right? But with Airflow 3, maybe one is me being really proud about it, but it's constant load. But the point is that 1,000 tasks will have just maybe 5 to 10 database connection and all through the API server now. So the database load is finally independent of the task count, the concurrent task count. And in a happy world, there can be unlimited horizontal scaling of task execution because of this. And finally, the dependency issue. Earlier, single Python process, you're trying to write a custom provider with a single conflict. It will not let you do it. And obviously, the task that you try to write with that operator will definitely fail. But with the next one, which is the supervisor process, as we call it in Airflow 3, you don't have to worry because Airflow core is a happy component in itself. The task runner is the one which is the task SDK, and that is the one that doesn't really care about core at this point. So if you write an operator that is depending on this, you can write your own provider with whatever version, right? Pandas 2.1. Then you choose to be brave and you try one more provider with a NumPy 125. Again, a conflicting thing, but you're fine because it doesn't really depend on that. And yeah, some people do TensorFlow as well, but okay. Yeah, so what are the wins here because of the redesign, right? So in terms of security and scale, obviously 0 DB access from task code. The database load has dropped from linear to constant. You're at a dependency freedom finally, where where you have a complete process isolation. You don't have version conflicts. And the last but not the least, you can use any Python packages that you want without worrying about what the core does. And in terms of developer experience, as a DAG author, you don't have to break your head every single time there's an upgrade or downgrade of Airflow, because you will always have a stable SDK API to work from, and all of us will be happy. Yeah, so what does this architecture also unlock as part of so when we did it, it also unlocked some benefits just because of the design. So what's the first one? The first one is definitely location independence. You can run from anywhere on your laptop. If you're interested in the cloud, you can run AWS Lambda, Google Cloud Runner. If you want more security, you can run it in an air gap cluster or a government regulated system, whatever works. And then also edge devices. This is something which has also been, it's also launched as a provider known as the edge provider. So that's already working on Airflow 3. Right. And the last benefit is this also unlocks language freedom for you in terms of which language, which programming language you choose to write your tasks in. So Python, obviously, we all know Airflow runs with Python, and there is full task SDK support for it. All the existing operators work, while some of them, they use the task SDK already, but others are under the process of migration. It will be done soon. Golang is already in development. We had a preview launched very recently over the dev email. So this is if you want to benefit from the native Go performance, or you want to run your compiled binaries with the same SDK interface with Airflow. And there are definitely some of these enterprise houses, right, where you're running Java-based legacy systems. So if you finally want to offload your orchestration to Airflow, you can just offload it away to Airflow and let the remaining part of your legacy system stay. And this will be coming somewhere around Airflow Summit too. And finally, this is not yet in plan, but yeah, just something that I think will be nice. If you have performance critical operations and you're running something with Rust and you want to run your tasks in there, yeah. If I ever start a dev email, please feel free to chime in. So that's about it. I want to conclude with Airflow 3 allows you to have one control plane, run your tasks in any language and anywhere also. So that's my time. Thank you. If you want to connect with me, these are my handles.
Hi, it was really insightful. It's a really great upgrade. I have two questions. First, how about backward compatibility? Because you are changing the whole to Airflow SDK. And the second is, if we are not able to access the database, if there are some requirement, when you say drop, that's a write operation. What about the read operations? That if we require, if we want to know what is happening in cross-task, then how? What is that? How that?
Yeah, good question. So backward compatibility with we're maintaining shims as of now. So you can continue using your older code, but eventually you'll have to migrate. At least we're giving it a few minor releases for you to bump. But as of now, the old imports just work. You will see some deprecation warnings, but it works.
It works on the upgraded thing, right?
On Airflow 3, you can run Airflow 2 code. It'll work just fine. And the second question was, how do you get around use cases where you're actually talking to the database and getting some information, right? So API is the way. Please migrate to REST API.
Okay.
It will not work with Airflow 3. You cannot do session dot whatever you want. You cannot. Most of the data, if you're accessing stuff with connections, variables, etc., these are all data classes. You can get it directly. But let's say you have a use case where you want to do, a number of task instances or things like that. It can be achieved with REST API. So yeah, please use that either directly or use the Python client that we already have for Airflow.
Yeah. Thank you so much.
Okay, so my question is related with database connection pooling. So connection pooling, yeah. So basically internally as well in the API server, we will be maintaining the connections somehow. So will it not impact the performance because the connection pool remain 1 or 5 or like it will slow things down? Like if we are 100 pools, things will run faster, obviously. So how exactly we are managing this performance and the speed?
Right. So again, good question. There's just one connection. It's a one connection per API server. API server is something you can horizontally scale if you wish, but n number of tasks will definitely go through a task execution interface to the API server in somehow, which will be having one active connection at any point of time to the database. So you don't really have to worry about pooling here because there's always one active connection.
Yeah, but performance will impacted.
Horizontally, you have to bump it up horizontally and
connection pool will be increased.
sorry?
Connection will be increased to single database.
Definitely. But it's not like if you're talking 1,000 tasks with 1,000 connections, you can make do with 3 API servers instead of having 1,000
correct
tasks. So it's a matter of perspective. You can obviously get the work done with horizontal scaling, but we've never seen problems with. We ran a few performance reports, and like even I was actually really surprised. It looked sweet. It looked better than the Airflow 2 version. So that's
got it.
good for us.
Thank you.
Wasn't that solvable with PG bounds or anything?
The pooling, yes, you can. It's more of a proxy to the database problem, right? Not really problem of Airflow, but yeah, it can be solved with adding PG bouncer or similar things. Yeah. Okay, so I'll be around till the end of session. You guys want to chat? I'm around. So thank you.
Good afternoon, everyone. I'm Atish and I have Samir, my colleague from Uber. And today we are going to showcase our efforts towards leveraging the power of generative AI for data workflows ran by our data workflow platform at Uber. So this is going to be the agenda for today. I'm going to go over Uber scale, the scale and criticality of data workflows at Uber, how the support experience story is like for these data workflows, how we improved it. So I think many of you must have used Uber to come here to this meetup. So yeah, Uber is quite spread out throughout the world. Over 70 countries, 15,000 cities, 180 million monthly users, and around 1.5 million Eats merchants. So yeah, it's pretty well known now. Here are some business critical use cases that Uber leverages our data workflow platform for. These include business intelligence and analytics like financial reporting, policy reporting. It includes fraud analysis, generating reports, And yeah, another very common use case is data science across Uber. So all these leverage data workflows, all these leverage our data workflow platform. So yeah, handling these critical use cases, we need a very scalable workflow management system. Uh, and that's what our data workflow platform provides. It's an all-in-one platform that provides no code as well as programmatic ways to orchestrate workflows for those all important use cases that I mentioned earlier. So one of the core aspect of that data workflow management system is Piper. It's a fork of Apache Airflow 1. It was forked in around 2017-ish, and it was heavily customized to handle Uber's huge scale and critical use cases. Uh, it's a batch engine which helps users to construct and execute complex workflows. It provides SDK as well as APIs to develop and monitor complex pipelines. And yeah, for the scale, we run over 450K daily pipeline runs, and it's just short of a million task runs each day. There are thousands of teams across Uber that use our platform, and yeah, we also get a lot of commits daily and monthly. UWork is the second half of the data workflow platform story. It provides users with a drag and drop UI. It provides real-time engine support. And it was born in around 2020. And this satisfies the needs for developing workflows in a very quick manner. Yeah, but Piper is still the very heart of batch data workflows, and it's one of the engines that is supported by UWork. UWork also, as I mentioned, provides a lot of cool things like versioning, drag and drop, test and deploy, along with Piper, which provides the core batch functionality. Now, Piper and UWork being the front face of batch data in Uber, to many people, we get a variety of questions on our support channels. As you might expect, because of the use cases I described earlier, we have a variety of users from software engineers to data scientists to policy makers, legal scientists, etc. So we get a variety of support questions on our internal support channels. For example, hey, my Presto query is taking too long. It used to finish in 5 minutes. My task seems to be in a queued state. Is there an outage going on? Or like any general architectural question, like how do I transfer my data from Spark to Tableau? So this means we have to cater not just to software engineers, but to whole variety of people, engineers, non-engineers across Uber who would like to use our tool. And so consequently, we have a huge support inflow. Around 150 weekly questions on Piper's internal support channel and 150 support questions on UWork's support channel. This consequently leads to on-call churn, heavy on-call load, and it previously led to a poor user experience, right? Because one single person has to handle all this. So this was until we improved the user experience support. And now Samir will go over the story of how we evolved Piper and UWork's support experience so that it can serve thousands of batch data users across Uber who use our product. So now over to Samir.
Hey everyone. So yeah, evolving support is quite crucial because say the product teams are also using our platform to write various pipelines that can solve a lot of critical use cases. Say there are a lot of teams, some teams do data analysis, they get to know, okay, how's Uber performing right now? All this is done by Piper. So if we like block the support, it will lead to like poor product experience overall. It will like we will not be able to move faster to develop pipelines and to use that. So yeah, starting how we improve the support. Even before like it's around 2017 or 18, it was a very simple concept. whenever user will ask something, so it will ask, okay, hey, something is wrong. Say the question is like, oh, my pipeline were deployed, but it is not visible. So what we do, we used to do a regex search, and see, you can, in the example, you can see if the question contains deployed and not visible and not found, then just respond with deployment will be in say 10 to 15 minutes. This is a sample Slack example I have added. So the issue with this is that there is no semantic search. Again, Uber is in a lot of countries, and also it has data, it has engineering centers in a lot of countries. So having rejects on some particular words is not viable because of the language barriers we have and other stuffs. Again, we have just hard coded these words: deployed, not visible. Someone can also write something that has my pipeline vanished all of a sudden because I don't see it. So again, this is not something that is very scalable. It has very fixed response. We can see there is no intelligence, and also it can give some false positive. You are asking something, it grabbed with some other word, and it is responding with some other answer. So yeah, like we improved upon this. And again, regex search was something even before the LLMs era. So after we have generative AI, we have a powerful uh, LLMs like ChatGPT, Claude, and all those stuffs. So we leverage that to improve. Now, like since we know LLMs can perform variety of tasks and summarization is one of them. So if you ask, hey, can you help me prepare a coffee? It will answer because it is able to understand what the question intent is, do a semantic search over everything, and not just limited to some particular words or hard coding. So yeah, again, RAG is one of the technique which also came up after the evolution of LLMs, that basically if you ask something related to Uber to a generic LLM, it will not be able to answer because we have some internal document, internal constructs. Say, like in Airflow world, you call it DAG, we internally call it pipeline. Again, pipeline is quite a famous word, so it might not be a best example. So we have our internal knowledge. So again, what we do here is the RAG will basically go into like those document and enhance the prompt and then query the LLM. So for that use case, we ingest all our NGV to open search cluster where all these knowledge base is there. So basically now we have a knowledge base that contains information about all the wiki. So whenever user posts a query, a Slack bot will take that query. It will perform a semantic search on all the embeddings we have in the knowledge base. So now the LLMs know a lot of context about what Uber is, what are the like constructs of Uber, and then it will generate a tailored response. So this solved a very critical use case that we have of NGV keys hopping. Since Atish mentioned that we are the front face of batch data, user can ask query because even the failure was on say Spark node or say Presto. So we have to make sure that we unblock our user fast by sharing the solution or by sharing NGV. So yeah, this solution helped us to overcome this. But again, like it still is not able to cater some of the use cases of say customized workflow. So say a user asks, okay, my pipeline is failing and it might create an incident. But the response will still be something like, okay, if your pipeline is failing, do this. But at that point, user would want a on-call should help it. So all these stuff. The other issue is that it has inability to perform action. Say there is some data about my pipeline. Like what is if user asks what is my schedule of the pipeline? Since it is not in the NGV keys, it is something that is stored in the database. The LLM will never be able to get that data. So it is not able to open links and all that. And through this, we were able to have a resolution rate of around 5%. Again, with for 150 queries, even 5%, if we are able to solve 10, 15 queries, it was good. But for most of the use cases, it didn't work. We still had high on-call churn. On-call has to reply to all the queries. That led to a lot of churn. So to further improve upon, we leverage another technique, and we use agents. So this is something you are lately hearing about agentic AI, where we leverage agents to solve the problems instead of using a vanilla LLM. So, yeah, before I delve into this, I will share some context so we are on the same page. So, what is the agent? Agent is nothing but a LLM that is trying to reason, and it is able to pull in information from, say, your APIs or through a tool. A tool is nothing but a function. It's just a function with a decorated tool in it. So, agent will use all these capabilities to answer your query. So say if you ask, okay, I want to book my flight tickets. So if there is one tool, say there is one tool of ClearTrip that allows you to search on ClearTrip and then get the what all flights it has and tries to book. Then the LLM will be able to do that also, because LLM is still able to reason on any text that it has. Now the other part of it is LangChain. LangChain has become quite famous lately, and it's an open source framework. I think it was developed around 2021, and is basically gives us the essential building blocks to create applications powered by LLM. It also provides us interface to connect to LLMs, provide prompts libraries and utils to import documents and interacting with agents. So this is something that is very helpful when you are building uh, production software. You don't want to write a code which basically call a LLM using ChatGPT library, fetches the result, performs something. So yeah, LangChain is very powerful upon that. Um, Now the third thing is LangGraph. LangGraph is again an extension over LangChain. It basically in LangChain you can create node. When this happened, do this and then do this. But there are a lot of complex use cases. Like if there is A, try to explore both B and C. So now it becomes a graph. Just like we have a DAG in Airflow, it will become a like DAG in LangGraph also. That when you get to this condition, try to think about this also, and then try to calculate your result and give it to me. So a simple example will be when some user asks to search for cheapest flight, search Google Flight, search Clear Trip, and then give me the results. So yeah, building upon these things, this is the architecture that we are leveraging now. So I will go over this and the important things that we have done over solving a query. So whenever we receive a raw user query here, firstly we pre-process it. By pre-processing, I mean is that since the data can be very unstructured, users can write anything, say, can you help me in urgent? Say, my pipeline is failing, and the user might not leave very much details, and all this will be unstructured information. Say a pipeline ID is there, it can be at the start of the problem, start of the query, or at the end of the query, somewhere in the middle. User can also share task ID, execution date, and all that. So in that node, we create a structured input, and also a user can post multiple questions, multiple queries, say 1, 2, 3. So this pre-process node will firstly create a plan. It will say, okay, now I have a list of questions that I have to tackle. And okay, in all these queries, I have these structured data. Okay, this is some code link, this is a pipeline link, and so on. Now, delegator node is kind of the brain that understand uh, how to how to deal with this query. So we have basically swarm of agents, and all these agents have a particular capability. So we have a pipeline a task debugger, which will debug anything. Say, if you give, okay, my pipeline is failing with trace this, or my just the trace logs, it will try to debug that. If there is also a pipeline anomaly agent, it will give you all the anomalies. Say, my pipeline is queued for a long time, can you help me? Or say, was there any import errors in my pipeline? Can you check? I'm not able to see it on the UI, which is quite frequent, and you all must have faced. So the other agent is the alerts and monitoring. So we receive a lot of questions. Say, okay, my alert was triggered, my pager duty alert was triggered. Why it was triggered? How can I resolve this and all that? Also the task can also fail due to not only execution time failures, but also if there is incident going on our side. Say there is an incident going on in which database is not functioning. In that case, we also want to inform users that, okay, your task was failing because you have some incident going on. Or it can be a general QA agent, which will do nothing but basically the it will grab from the knowledge base whatever NGV keys you have written. So the delegator node has registry over all the agents. So whenever it receives the query, uh, it will ask the LLM that, okay, I have this query and I have these many agents. Which is the best agent to tackle? At times, it will answer, okay, since your task is failing, go to the pipeline task debugger. But there can be multiple agents also. So yeah, a delegator node will basically delegate your query to one or more of to the agents, and then all these agents use tools or external services, say connecting to our web service to gather the data. So I will talk about one of the agents flow of how it works. So probably there you can understand it well. And these agents perform their investigation, and they all send a list of investigation, and the synthesized node uses the knowledge base, our knowledge base, so to answer it Uber specific, because there are a lot of things we developed in like Piper, which is nothing but a fork of Airflow in Uber context. So all these the vanilla LLM will not know. So that's why we leverage the knowledge base to basically enhance or enrich the final answer, and then we send it to the user. And through that, now we have very high knowledge coverage, because the knowledge is not only limited to NGWikis, but also all the APIs that we have or anything in the database for which we expose API. Through this, we were able to get 40% resolution rate up from just 5%. So this has helped a lot to reduce the on-call churn. And again, this is a very high extensibility. As soon as we keep adding new features, we also can develop up agents in parallel. So that agent will take care of that query. But one of if we think through this, again, one thing missing into this is no human in the loop. Not everything can be solved by LLM because it has only limited information, limited by both APIs and then like any programmatic flow. Say a user ask, okay, I need some urgent help because again, I need help from on-call, it might turn out to be incident. So that is not there, and this is something we are working upon. So yeah, this is one of the shortcoming. But coming to deep dive of one of the agent. So as I like mentioned earlier, we get a structured query from the pre-processed node to the delegator. The delegator will select one of the agent. So suppose the query is my pipeline is running from say last 1 hour. It used to complete in just 5 minutes. Can you please help? So once we received a structure query that will contain the pipeline ID, task ID, and whatever information we have, and also the original query. So we firstly check if the query contains pipeline ID. If it does not, we ask user to provide those details, because without the pipeline ID, we won't be able to tackle it. But if the query does contain a pipeline ID, we go and get the task log for this run. Again, at times the user might not even provide task ID or execution date. In that case, we go to the we fetch all the running tasks for that pipeline. We see, okay, is there a recent failure? And then we take the most recent failure, and then we basically work on that task instance. And then we process these logs. Why processing is important is because the logs can span over 1,000 of lines. We have seen logs going to over 50,000 lines in case of, say, a Spark job is running for the last 2-3 hours. So we perform some post processing, we dedup the logs to only include some, remove some duplicates among the log lines, and also keeping the important part where some error can be there. And this is also important because LMs, as per their property, they have some context window. Say for ChatGPT is around 200K. So if you give a word, if you give a paragraph that has more words than 200K, it will straightforward failure call. So we have to make sure we don't go into these issues. And then after we process these logs, we fetch the relevant engine. Say we fetch, okay, was this task running on Spark or on Presto? And based upon the response, or it was a generic task run, say a very simple Python task or something. So based upon that, we say, okay, is there a queue congestion on Spark, or is there a queue congestion on Presto, due to which the query is not even coming to the starting state, and so on. or the generic solution will be to check the logs and see in the logs if we find something that, okay, your process is stuck somewhere. And then we respond back to the user upon that. And in here, you can see we have used LLMs to reason. We firstly reason by what is the task log, what was the recent failure. We reason it to get, okay, where the task is running. In fact, there's also one more step. We also reason to understand the intent behind the query. Whether the user is really asking about a long running task, a failed task, or say a skip task, or and so on. And that's how we use the delegator node. Again, since we are the front face of the batch data platform, we route it to specific like engine also. If we see that the issue is from Spark side and we are not the Spark expert, we will say, okay, you can contact Spark channel to get further help, or you can say contact Presto channel for further help. And through that, we are able to solve complex flows into this. So like improving from the previous uh, technique where we just use racks, we can see we are able to leverage APIs and also the tools to answer to the user query. Then coming to the impact wise, we can see a lot of user feedback. These users are the one that might be from the product teams or say platform teams. And like they want us to unblock them like as soon as possible, so that they can move faster, they can deliver their products faster. So yeah, this is some user feedback. And here we can also see how, like, as soon as we rolled out more agent, we see an increase in the accuracy of how our bot is answering. So now, for now, we have a resolution rate of around 40%. So this is a sample answer also I have attached. So in here, a user asks that, okay, my pipeline is in queue state. Can you help me? So we are able to answer, okay, you are in queue state because you are using a Uber Eats pool, and that pool might be congested. And you can check this Grafana dashboard to understand like about your queue metric. So all this is only possible because we have built agents to cater these use case. And through this, we have seen a lot of decreased, like a lot of less on-call churn. And this also help the on-call to resolve the query in much better way. Because if the on-call is already exhausted, it might not be able to answer very well. So through this, we are able to help to improve the support through AI. Now, there's also one more thing we face quite often, is that user want us to debug their task. Again, we own the platform. Users can write any DAG, and it can be a silly mistake or some very complex mistake. So on our UI, we have given two buttons. One is to summarize the logs so that user can understand, okay, what is the pipeline even doing? And the other one is to help to show them mitigation step, that, okay, your pipeline failed because it was the error, and how to fix this, any references or further reading that you can have, and also any source URL that you can it extract the information from. Since the users of our platform Piper are not only limited to software engineers, they have a very tough time debugging their task, because this is not something they do often. They can be, as Atish said, say legal director, which is, or a data analyst, which is writing the task to just analyze the query. So this feature we are seeing quite adoption, and users are using these to get the mitigation steps. And this makes our support self-serve. Again, the other queries can be asked on Slack support also, but this is one of the important things that we carved out on the UI. So yeah, this is something that we worked upon to improve our support. Yeah, you can connect with us, and yeah, we are open to any questions that you have.
It's a long running DAG and it has produced a lot of logs. And all of a sudden it produces a chain of exceptions. So in Python, let's say we are handling multiple functions from top to bottom, and we have handled the exceptions. So how you analyze the logs, like as you mentioned, like there is a token constraint with all the like GPT, or it's whether it's a Gemini. So like how you manage, like from where to log, like from where to pick the logs and where to summarize, so that we get the exact error
Yeah, so again, this does not have a definitive answer on where to extract the log, but I will tell some of the techniques that we have used. Firstly, internally, we are using Gemini, which has 1 million context window. It is more than what of Claude, that is around 400K right now, and ChatGPT 200K. The other things we have done is post-processing on logs. So we have seen that there are some logs that are not very much helpful. So we have intentionally excluded that. We have also excluded logs related to timestamp that we don't need. We also have dedubbed the log. Say if a similar log occurred in last, say 10 lines, keep only one of them. So if you are printing something like, say, you're printing, okay, my function is running. So we trim that log because we know if something is getting repeated, this is not something new that has come. This is the normal behavior. So we have trimmed a lot of noise also. And we also like made some searches that, okay, whenever like make sure you always include something like import error, like say you get a keyword by import, say you get a keyword something like not found, say you get a keyword by a failure. So all these keywords we have also intentionally extracted so we don't miss out. Again, if still it exceeds, what we have done is we make sure to make multiple GenAI calls by breaking the whole logs and then again summarizing it. So we call it two-pass summarization. So through that, we don't miss anything. But again, as the number of passes increase, the quality of the answer also goes on. So firstly, we make sure we only do it in one pass. And then if it does not work, it still exceeds, we break down the logs into multiple like parts.
Hey, hi. My name is Prajwal. I'm currently a fresher learning person, data science. So, okay, I know how to integrate the LangChain, how the tokenization work with the ChatGPT and everything. At the end of the day, when I used to create a project, there's in two options, like using the programmatic language to build an agent using Django or something like that. At the end of the day, same effort used to go, the effort used to be less using the applications like NA10, Google Opal, something like that. So as a fresher, if I wanted to create in projects using GenAI, LangChain and everything, how can I build a concepts to create in projects and everything?
Okay, so as a fresher, I would say this was also something new when I started to build this. I had no prior knowledge in LangChain or LangGraph, anything. So how I started is by reading some of the documentation, and I also leveraged ChatGPT to basically I used to tell him, okay, I am facing this error. Can you help me unblock that? And I also made sure to understand the bits and pieces of the library that I'm working on, because it is very important to understand what you are doing.
Yeah.
So like I firstly understood why even LangChain exists. Why do we even need that? And also like how is it different from writing a simple application and making a ChatGPT call?
Yeah.
So firstly, I delved into that part. So once my concepts are clear relating LangChain, then I further move on to just create a very simple working. Again, in Uber, we have a lot of extraction. So even just by writing one line of code, we will have an application ready. So again, I have not faced that issue of creating a application from like scratch. But again, for the in general runbook here is to like go step by step, ask Chat GPT or Stack Overflow for any blockers that you have.
So my basic question is, see, if I wanted to make the email automation, generating an email using the LangChain and everything, we can do using code and everything, right? Using the Google API and to create an body of an email, we can use the Chat GPT to giving a prompt in a variable. Okay, at the end of the day, in NA10 also we used to get the LangChain is integrated in that. We used to connect the APIs right over there. So if I wanted to differentiate between both of these, because so many agentic AI applications is coming, so how can I create my concepts to build a project using LangChain?
Sorry, maybe I'm not able to understand. So
Yeah.
I
What
am
kind of project concepts that I can get to build a project?
By project concept, you mean starting a LangFX service from LangChain service from the scratch, or like getting through the blockers?
Like automation workflow. If I wanted to do the workflow automation using LangChain, can I do it using the LangChain and Django, something like that?
Yeah, see, firstly, LangChain is itself a framework, and I believe Django is also a framework only.
Yeah.
So LangChain has its own use cases. Again, you have to first separate on what you have to build. If you want to build something that is interacting with LLM and then is making decision making, say the thing that has changed with LLM is now you have like programmatic reasoning. So if you will say LLM that, okay, tell me what is 2 plus 2 and give me answer in always alphabet, don't give me 4. So it will be able to do that. So if you want to have programmatic reasoning, then LangChain will be very helpful.
Thank you so much.
Hello. So, so in the architecture, I didn't see any guardrails because you have so many diverse data. So, is there a guard? So, in the architecture, where do you put a guardrail, and what is your guardrail? How do you prevent, right? So, there are so many people that is accessing the data. So, you would want to limit the data for particular users, or is there any cases like that? And what is the guardrail strategy that you are creating?
So we only provide LLMs with the APIs or the DB access that users also usually have, but they don't know the names of those databases, the names of those APIs, the names of those documentation. So this facilitates the access of those databases pretty easily back to the users. All those tables or all those APIs are publicly exposed only, and we don't provide right now. All of our agents in the our LangGraph architecture, they don't have write access on anything. So yeah.
So data read can be from any place as of now.
No, from
Based on the query I make, I can get data from.
So let's say a user asks that user wants to know ki, why did my pipeline, why did my workflow was running for 6 hours yesterday? We do provide task log access to the users on the UI. We provide the LLM with the same, but user, because they might not be able to understand the logs, LLM understands on the behalf of the user, provides them that this is the reason your queue was congested, there was some resource bottleneck that caused this. So anything that the LLM has access to, the user also has access to. It just provides easily facilitation to the user.
And adding to that, in Uber, we also have internal services that make sure that whatever call you make to LLM is firstly scrutinized. So you cannot just send any sensitive data related to Uber. Any business related data is trimmed or any key is trimmed. So all those guardrails we have on the like what we send to LLMs. And again, user has only some part of access, like they can only see which we allow them to. And also same when they like give us any query, we also perform only those action which, and we make sure we don't perform any write action. So if the user asks, can you trigger my DAG, we won't allow that because we don't want to allow any triggerance automate in automated way. So all these we have built in, which we trimmed here because there are a lot of lot of internal Uber constructs that already we have.
You're using Gemini right now.
Yeah, so in Uber, we have abstracted model to use any of the LLM. So right now we are using Gemini.
All of these agents can use different models, by the way. For summarization, we use Gemini. For complex reasoning, we might use GPT-5. So all this is configurable on a per agent basis. Yeah, exactly.
I'm interested to know about your infra size to run the agentic AI at Uber. Like Uber scale is very high. So at that scale, what is your infra
Yeah,
size?
so again, we provide platform for users to write pipeline. There is another team, you can read a blog about that, Michelangelo team, that provides the same platform to run your basically LLM related apps. So that make sure that any call that you make to LLM does not fail. So they manage all the infra related things that, okay, uh, this should be the, like how many chat GPT calls we are allowed. It makes sure that it's in the budget. It makes sure everything related to how you can interact with LLMs. And we are the basically customers of them.
Okay.
Sorry if you have any question.
No, I don't get the answer, but I think you are not the right.
Yeah, again,
team,
like
basically.
if you are
Fine.
interested in how much, again, we make a lot of LM calls. There are a lot of teams that make LM calls. So I'm sure the cluster, or basically we are one of the biggest, we might be one of the biggest user of chat GPT or say any LLM. But again, I don't have those numbers because I'm not in that
That's
team.
okay. Yeah.
Hi. So can you double click on the tools that you use to leverage relevant information from logs so that you provide LLMs with a limited context? Because sometimes you'll have to tie the logs of Spark or Presto workers or coordinator along with the task instance logs. So how do you, I mean, what do you use to prune or identify those log segments? Uh,
So let's say your task instance launched a Spark job, right? So it must have some indicator if your job is launching the Spark job, right? Internally, exposed throughout the logs. So let's say we provide the logs to the LLM. We have a reasoning built in that which downstream does it connect to? Does it connect to Spark? Does it connect to Presto? If it connects to Spark, it must have a unique identifier of some sort. We send that identifier. It can be different identifiers in different companies, right? We send that identifier to the Spark support agent or support API. That API gives us back the logs, and that we pass to the LLM. It's able to understand if this error has occurred before with the help of the knowledge base, and it provides the answer back to the user.
yeah, so sometimes driver logs can be very heavy. So how do you prune those log segments just to help LLM debug better?
So, are you talking about the task logs or like Spark logs?
Spark logs. And
That I think for us, thankfully, the Spark team provides the trimming down on their side. But yeah, similar for the teams that don't have this, we do the similar kind of pre-processing that we do on task instance logs for those engines as well.
can you double click on what kind of pre-processing you do?
Sorry, I didn't understood.
Yeah, so can you double click on what kind of pre-processing approaches you take?
Yeah, as I told, sorry, firstly, it's post-processing. So once we get the logs, they can be of huge size. So firstly, we read up. So if some log has occurred in last 5 or 10 lines, we remove it. Then we make sure to include. So the same answer that I gave earlier. If the logs is still exceeding, we break down in multiple parts and then make the call.
And one simple heuristic that we use is that if the user has configured some retries on their task, and if they still come to us that why did this behave this way, so only relevant log would be mostly the last runs log, not the ones before that.
So one question, so you're using LLMs for the everything, and there is very specific details that you have to do if the user asks this, the user asks that. So you're creating a database of this whole details of everything that you're feeding to LLMs. Once this size increases, at point the LLMs will start to hallucinate. Once it hallucinates, then how you're dealing with that first, and something occurs, then how you're dealing with the responsibility, because LLMs are machines, right?
Yeah, so again, we have seen lot of hallucinations, and like over last 6 months, I have also seen that as soon as the model have improved, the hallucination has also reduced. So for that, to have less hallucination, it is always important to isolate your problem. Say, if I have only one node and I write a very big prompt that if you see a task failure, call this API, get the logs. If you see some anomaly, do this, do that. If you see alerting related question, do this, do that. So that's why we have a delegator node. Delegator node will only check, okay, I have 5 agents. This is my original query. I will generate which is the best agent among them. And also, if I'm confused, I can also give 2 or 3 agents, the top 2 or 3 agents. Now I will only isolate my problem to, okay, you are now expert in task debugging. So with isolation, we also reduce the scope that LLM has to deal with, and then we get a better answer. And again, it's not hallucination free. We have seen wrong answers also. And again, this will be something that will be improved upon both as soon as we get more data, and that will be fed into the knowledge base, and as the model will improve.
Thank you.
Yeah, so the thing that is centralized is basically all the LLM calls, all the or the Lang chain framework that we have. There's something we have built for our team, and the reason is because we are the in bad data we have the highest number of inflows. Again, some teams are also building the same, so it might evolve into some framework. But for now, this is only 2-3 builds teams have built, and we are one of them.
Just to add on to the answer to your question, all these large language models like Claude and GPT, they also have something now called structured output. So if you want it to respond in only a certain number of ways, you can tell it with the help of structured output that just answer in a JSON format that I can use further on. So anything like we want to parse from the output of the LLM, like that any of these further agents might need something that is pre-processed by the pre-process node or the delegator node. So we instruct these nodes to have structured output so that these can be used by the agents further on so that our program doesn't break. Yeah, so explore on structured outputs, it would help.
Yeah, so again, this is a tough problem, and we haven't built an automated way to measure the hallucination. It's more of like even after the Slackbot posts the answer, like we read the feedback from the on-call that, okay, this is a wrong answer. Can we check why it failed? Or like why the response was not up to the mark? And this is kind of very manual right now.
Thank you so much, Atish and Sameer, for the wonderful talk. Feel free to ask more questions. I know you must be having more coming in mind, while listening the talk. Connect with all the speakers after this. We have networking session. Then you can connect, please. We are running late. So now, thank you. I'll ask Vaibhav from our talent acquisition team to come, and he will share about the Cloudera culture and if there is any open requirement and all that. So you can connect with him about it later also.
Thanks, Samriddhi. Hello, everyone. As Samriddhi mentioned, my name is Vaibhav, and I'm a part of TA team here at Cloudera. First of all, I would like to thank you, everyone, for joining the session and being such an engaging audience. So with Cloudera, we work with open source every day and help enterprise scale data platform. We are a extremely people-first company and always in hunt of talent. Please feel free to visit Cloudera career page, or you can scan the QR code. Thank you, and I will be here till end of the session, so let's catch up if anyone is interested to work with us. And thank you a lot for your time.